As always, I will demonstrate you my screen.
I think that Nicholas is not here yet.
Yeah. Okay. We will wait.
Maybe he's here. No, not yet. Not yet.
No, I don't see two.
I can see only 3 of you. So maybe someone can write him a message or.
Yeah. Oh, he's connecting, I think.
Okay. Okay. Can you see my screen?
Yep.
Yes.
Okay.
Yes.
As always, we will need a workbench for this profiling stuff. So now you can open the program. I will wait for Nicholas. So and of course you will need the finished calculation of turbo machinery stage, and you told me that you've done all of you have finished this calculation. Yes.
Yes.
Yes. We finished.
Okay, perfect. Today we will start with only the first part, which is profiling part. It's quite long, I would say. That is why I think we will not be able to do the next steps like mesh and preparing the computational model. All of this we will do next time. And maybe I think today we will work with my data. I mean, you will not use your results of your calculation. We will do the same parameters together. Maybe for the next lesson you will prepare your own blades and you will do the mesh for your own stages. Oh, Nicholas is here, I suppose.
Good morning. Sorry. Sorry for the delay, but I have problems in the microphone as usual.
Typical Italian.
Everything is okay, don't worry about this. We're just discussing some organizational stuff. And I think next time you will be ready with your own profile blades and you will do the mesh for your own stage to not spend too much time for the double work. I think this is logical.
Okay.
So let's start with our lesson. So first of all, let's discuss what data we will need for the profiling of the blades. I've sent you today the small presentations of several slides. The initial data for compressor and for the turbine is very similar. So we will need the values of the angles and the hub and shroud sections. Maybe in the middle one, it will be up to you to decide in how many sections you will do the profiling. But today we will do the profiling only in 2 sections, the hub and the shroud. So for the rotor blade, you will need beta 1 and beta 2, and for the guide vane, obviously this is alpha 2 and alpha 3. Next, we will need the number of blades that you also have in your calculations, but be ready that the number of blades will be changed during the profiling. So it could be bigger or it could be smaller. It will depend on the parameters of the blade that we will get during the profiling. So, okay. But of course we will need some initial data. Then of course we will need the radius. Actually in your calculation you have the diameters like hub diameter, at the inlet shroud diameter, and in the second section and in the third section for the compressor. So, but in the blade gain program, which we will use for the profiling, we will use the not the diameters but the radius. Yes, the radius. Next, this length of the blades for all guys, you will have the same dimensions. And as you can see, we will have not only the blades itself, but the area, for example, the inlet area before the rotor blade, some space between the blades, and the area after the guide vane. And the sizes for these areas, they will be the same for all of you too. And it was like experimentally found that it is better to have the sizes of these areas which is equal to the length of the blade. So 50 before the rotor blade and 40 after the guide vane.
Okay.
And we will do the profiling separately for the rotor and for the stator, for compressor and turbine. But further, we will need to combine these two blades together. That is why it's very important to think about a coordinate system in which we will do this profiling. And the boundary between these two blades will be in the middle of the axial gap. So axial gap for all of you is 10 millimeters too. So the boundary will be in the middle of this axial gap. And for the turbine, it's exactly the same, but first you have here stator blade and rotor blade then, but you will need all the same radii and angles, but also for turbine you will need a stagger angle gamma, which can be calculated, and we'll discuss it a little bit later. Now we are going to workbench, and I will show you what will be the whole chain of the CFD calculation. So do not forget to save your project. And
Yes.
we will start with the compressor, because profiling of the compressor is more logical and it is based on more obvious criteria than for the turbine. So, as I told you, we will do profiling in the blade again program. So you need two of them on the project schematic. Separately, one is for the rotor blade, and of course the second one is for the guide vane. So together we will do first compressor and then by my data, and then we will do the turbine.
Okay, just a minute.
And of course you will have this this recording in the Skype conversation, so you when you will do your own profiling, you can replay this once again, and I think it will be helpful for you too.
Oh, thank you.
Okay, and just I have a question. If we are doing turbine, we are doing the compressor tutorial too or not? Okay.
I think it will be useful for you in the future. You will know how to do this.
Okay, perfect.
Okay, I mean.
So we'll have these two blocks for the profiling stuff, and the next step is to do the mesh for the blades. And the mesh also we will do the mesh separately for the rotor blade and for the guide vane. So you select this blade design, then press right button of the mouse, and you need to find the option transfer that data to new, and almost in the end you have this turbo grid.
Okay.
And the same stuff you need to do for the second blade. Again, right button of the mouse, transfer data to new, turbo grid.
So turbo grid is for meshing.
Yes, turbo grid is for meshing, and it is very suitable for turbo machinery, and it has some templates for generating structured mesh for turbo machinery in the most simple way. So that is why we will use TurboGrid. And of course, after we will perform the mesh generation, but in TurboGrid also the 3D model of the mesh will be created, or sorry, for the blade will be created, and then for this model we will generate the structured mesh. And after we have the geometry, the mesh, we can start with pre-processing of our model. That is why you press on the turbo mesh, again transfer data to new, and please select CFX. And the second turbo mesh you just need to pull to the first setup. So you need to combine two TurboGrid boxes in one CFX project.
Okay.
So as you can see, two blades are combining in one CFX project. That is why it's very important that these blades will be in one coordinate system to avoid some mistakes during the preparation of the model. Of course, if you will have some mistakes with the coordinates, we can fix this in setup. We can move blades, but I mean, it's better to avoid these problems at the very beginning, and to do like all the stuff in the proper way from the very beginning. So our area of interest today is profiling. And for the compressor, of course, we will start first with the rotor blade. Double click on blade design.
Sorry.
Is everything okay?
Yes. I see the screen a little bit cut on the edge. I don't know if it's just me.
Where, Guido? Bottom, left, right?
No. The screen of you, Daria. I see your screen cut on the edges. It's not full screen. I was trying to adjust something and I took a screenshot.
Let's try to for me to show you. Just a second.
But Guido, I think the problem is you because your screenshot is normal.
Yes.
Yes, I was trying to put it full screen and I took a screenshot. Okay, now it's okay. Now it's okay.
No, it's okay. Okay, perfect.
Yes, now it's okay. Perfect.
Okay,
Thank
so
you.
let's start with the very first actions. So we need to create a new project here. And for both compressor and turbine, the very first steps will be the same. And you need to use this one, normal Excel tab, to perform the profiling of Excel compressors and turbines. So what can we see here? For now, we need to set up the coordinates of the blade itself. I mean, we need for this, starting from this red point, to define all the points of the blade. In our practice, we assume that the zero coordinate will be where the red point is located for the convenience. That is why we are starting with the following. Second. So Z, it is axial coordinates. R, it's like radial coordinates. And we will start with this first point. Here we will have 0 for Z, and here 0 as well. And for the second Z coordinates, we will have 50. Well, so we are working with millimeters. And then we need to set up the radial coordinates. We also have all of them. So this is the first section, this is the second section. So you have all the coordinates on the slide as well. For this is 295. This is hub section. For the shroud section, in the first one we have 496. For the hub section, for the second one we have 303. And for the shroud we will have 488. So at this stage, for the compressor and for the turbine, there will be no difference at all. And for the other blades as well. The only difference is going here when we need to select the mode using which we will construct our blades. So for the compressors, it will be the first one using the angles and the thickness. And for the turbine, it will be the second one using so-called pre-churned methods. But now we are focusing on the compressor, so please select the first method and press OK. Here in this window, we need to set up the number of blades. For us, it's 35. But with the number of blades sometimes could be the problems because when you will press OK, the program will generate some initial geometry of your blades, and because, for example, of too high blade number, could be some errors during the generation, and the program will give you an error. So in this case, you can use very small number of blades, for example, 2, I don't know, 5, something like this. And further, after setting up all the parameters, we will increase the number of blades, so don't worry about this. So, and also you need to set up the number of layers in which we will correct the angles and the thickness. So as I already told you, we will work today with only hub and the shroud section, but if you are interested, you can use also the middle section for your blades. It depends on you, but 2 layers is okay for the angles and for the thickness as well. And the out, which is equal to 5, means in how many sections we can like see the results of the blade profiling. So for the 2 sections, for the hub and shroud, we will do the parameters by ourselves, and for the rest 3 sections, the program will generate the blade profiles based on our data, but automatically. That's all. We press OK here, and I will spend my so what we can see here. Just a second. Do you know if I close this window, everything will be okay?
Yes.
Okay, what can we see here? We can see 4 windows. the first window is showing us the meridional appearance of our plane. Then this window have two graphs. It's correspond to the angles. This window is correspond to the thickness, and in this window we can see blade-to-blade sections, 3D section, and some other information about our blades. So the first very important step here is to set up the units of our projects. So we are going to Model, Properties, and we need to set up the model units as millimeters. Because if we will forget to do this further, we'll have very big problems during the mesh generation. And that's okay. The next step for both compressor and turbine and for all the blades, we will need to define the length of the inlet and of the outlet area. So we remember that here, this is our 0 coordinates, and we remember that the length of the inlet, just a second guys. Here will be the length of 50, and this the length of outlet area have to be the half of the axial gap. So you need to double click on the point to correct its coordinates. So for this, for the left point, the horizontal coordinate will be -50. And for your projects as well, the coordinates will be the same. So we know that this coordinate is 50, and the half of the axial gap is 5. So the horizontal coordinates for the right line will be 55. So, and this line is exactly the line by which two our blades will be combined in CFX project. So this is the first preliminary view of our blade. For both graphs, you can see on the right several points. The red point means that it's active layer. The black points, that means the points in which we can correct the parameters of the layer, and the gray points, just we can view the parameters of this layer, but we cannot correct it. So because we select only 2 layers hub shroud, so we have only 2 black points. So what else? Now we can start to set up the coordinates for the hub sections. You need to double click on no sorry, it's for the turbine. So we will start with setting up the angles for the hub section. You need to click right button on the graph and find the option Adjust Blade Angles. And here
where is the option? Right click?
Right click, and the first line, Adjust Blade Angles.
Okay. But I can't select that.
Maybe you have forgotten to select the hub section. You try to, yeah. You need, sorry.
I need to select the middle.
No. You need to select the hub section, and in hub section you will be.
Okay. Yes. Now yes. Thank you.
So because, for example, if you select the gray points, obviously you cannot adjust angles because we've selected only 2 layers for the parameters.
Okay, yes, I was messing around.
So what can we see here? We can see the tabs for the leading edge and for the trailing edge of the blade. And for this leading edge and trailing edge, we need to set up only one parameter, which is beta 1. But in this case, you can see that beta is setting up from the X, but in like Russian practice, so that means in your calculation, we have calculated all the angles from the front of the cascades or from the leading edge line. That means for us, we need to set up not the beta itself, but tank beta, which will be 90 degrees minus beta. So beta 1 here will be for us, just a second, 62. And you can see that automatically you will have the values for the beta.
Mm-hmm.
And the same for the trailing edge too. The beta in hub section will be 82. Actually, this is some kind of checking your results. You know that for the compressor, for example, beta 1 is lower than beta 2 and alpha 2 is lower than alpha 3. And for the turbine, it's vice versa. For example, beta 1 is greater than beta 2. This how you can check your results, but I think all your results are correct. Just if you have some mistakes during the setting up this table, by this method you can check up that everything is okay.
Okay.
So yeah, we have all these set it beta 1 and beta 2. So for leading edge and for the trailing edge, and we'll press OK. Here on this graph we have two lines for theta and for beta. Theta is like a changing of angle coordinate, and it is more suitable for the centrifugal compressor. And beta is the changing of the angle along the length of our blade from leading edge to trailing edge. So in other words, using beta, we will describe the middle line of our blade. So because we will use only beta information, you need to press right button and select beta definition. And you can see that now beta is described by many points. Maybe it's good when you have a lot of experience in profiling blades, but for us, for now, it is okay if the beta will be described by only 2 points, because that is, in this case, you need to do the following. Press right button on the graph, find the command convert points to spline, and you need to set up the number of points, which will be equal to 2 points.
And sorry, can you repeat the last things?
So you need to press right button again on the graph, find convert points to, then spline, and set up the number of points for 2
points. Okay.
So now the changing of beta along the length of our blade will be described by the linear dependence. And now we can see the appearance of our blades, which is more or less, just a second, which is more or less similar to the blades now. But of course, it's not the final variant. The first problem for us that we can see that the trailing edge is cut off. Such kind of the trailing edge shape is more similar again to the centrifugal compressor, and that is why we need to change the shape of the trailing edge. We go into this menu, to this button, Blade Properties. And we need to find the tab which is called LETE ellipse.
I think I have a problem because my blades are different than yours. I'll let you show. These are my one.
Just a second.
No, but this is not mine. Okay, no, this is your screen. It's not my screen. Okay, just okay. Okay, I don't know how to do it. The shape of my blade is the same as before. It's just two lines very near.
Is there a problem?
Hmm?
Since she has a problem.